Hi, everyone. We'll get started in about a minute. Okay, it's 6 o'clock and I'll get started right now. All right, so last time we left off at adding and subtracting fractions. So we went over the slide already, but I'll go over it again. So there must be a common denominator when you add and subtract. It's not like multiplying and dividing. So 2/7 plus 3/7, that's 5/7. 1/3 plus 1/9, you have to find a common denominator. So you got to multiply 1/3 by 3/3 to get a 9 in the denominator, and you get 4/9. And then same thing for the other ones. So just find the LCM of both of the denominators, and then you can add the numerators after that, or subtract. And you guys should simplify the fractions before adding and subtracting, just so you guys get smaller numbers, and it makes it a lot easier. All right, so last time we left off here with some challenge problems. I want you guys to go ahead and get started on these. I'll give you guys about 6 minutes, so a minute for each. Yeah, you guys don't have to do these problems, but I would like you guys to, just to see how you guys are doing. But obviously, it's your preference.
there going to be a Kahoot today?
Yeah, we will. Once we finish this unit.
Thanks.
Okay, about 1 more minute. Okay, I'll give you guys about 2 more minutes then. So until 6:10. Okay, so I'll go over the answers right now. If you guys didn't finish, it's okay. Just do as long as you guys did as much as you guys can. All right, so I'll go over the first one. So 2/3 plus 3/4. So you look at the denominator, you have a 3 and a 4, and the LCM of those two numbers will be 12. So you want to get both of the denominators into 12. So to do that, you multiply 2/3 by 4/4. So 2/3 times a fraction 4/4, and that will give you 8/12. And then you multiply 3/4 by 3/3, and that will give you 9/12. So now you have the same denominator, so then you add them and you get 17/12, or as a mixed number, 1 and 5/12. We'll talk about mixed numbers later or very soon. All right, 9/8 minus 11/12. So the LCM of 8 and 12 will be 24. So you multiply 9/8 by 3/3, and you multiply 11/12 by 2/2. And then you convert those fractions into 27/24 minus 22/24, and then you get 5/24. So when we multiply by fractions such as like 3/3 or 2/2, we're not changing the fraction. It's still the same value, but it's represented with different numbers. So so it's the same. It's still the same fraction, but we can now add them together. Because when we multiply by 2/2, we're really multiplying by 1. So it's still the same thing, because 2/2 is 1. All right, over here. So 2 to the negative 1 power plus 3 to the negative 1 power. So if you guys remember our negative exponent rules, so when we have a negative exponent, it's really 1/2 to the first. So this 2 to the negative 1 power will be 1/2, and 3 to the negative 1 power will be 1/3. So when we convert, and then we can convert those into different fractions with the denominator of 6, and that becomes 3/6 plus 2/6, and that equals 5/6. All right, over here in the bottom left. So for this one, we want to simplify the first two fractions first, because they can be simplified. So 24/6, each one has a factor of 8, so we can take out an 8. So we divide by 8/8, which we're really dividing by 1. So that becomes 3/2. And the 15/9, they both have a common factor of 3, so we take out a 3, and that becomes 5/3. So when we rewrite it, it's really 3/2, 3/2, plus 5/3 minus 7/6. And they all have a LCM, least common multiple, of 6. So for 3/2, we multiply by 3/3, and that gives us 9/6. For 5/3, we multiply by 2/2, and that gives us 10/6. And we don't need to do anything for the last fraction because it already has a 6. So we're good with that. So now all we got to do is add the top, add and subtract the top. So that gives us 9 plus 10 minus 7, and that equals 12. And 12/6, that is 2, because 12 divided by 6 is 2. All right, 1/2 plus 1/5. So an LCM of 10. So multiply by 5/5 and 2/2. And that gives us 5/10 plus 2/10, and when we add the numerator, that gives us 7/10. And the last one, we gotta find the LCM of the top and the bottom. So 2/3, we multiply by 2/2 to get a common denominator of 6. So then that's 4/6 plus 5/6, and that gives us, on the top, that's 9/6. And then on the bottom, 1/2 is also 2/4, 2/4. So 3/4 minus 2/4, and that gives us 1/4. So 9/6 divided by 1/4. That's really 9/6 times 4. because when we divide by a number, we multiply by the reciprocal, and the reciprocal of 1/4 is 4. So 9/6 times 4 times 4/1, that gives us 36/6, and the answer is 6. All right, mixed numbers. So 39/4 is an improper fraction. This is because the numerator is greater than the denominator. So when we have that, it's called an improper fraction. Normally for fractions, the numerator is smaller than the denominator. So we can turn this into a mixed number, and 39/4 as a mixed number is 9 3/4. So the last two bullet points show how to convert from one to the other. So to convert from a mixed number into an improper fraction, so it's 9 over. We want to convert the whole number, which is 9, into a fraction over 4. So 9/1. So 9 is really 9/1, and we multiply that by 4/4, and that becomes 36/4. And that's still the same thing as 9 because 36 divided by 4 is 9. So we have 36/4, and now we can add that to 3/4. And we just add the numerator, and that becomes 39/4. So that's how you convert from a mixed number into an improper fraction. To convert the other way, we divide 39 by 4, and you get a quotient of 9 and a remainder of 3. And then you just put the remainder of 3 over the denominator, which is 4. So you get 9 3/4. All right. Harry Potter fans, anybody? 9 3/4? All right. All right. 12 2/3 plus 9 1/2. So this is adding mixed numbers. So first, we can add the fractions first, and that makes it easier. Because 9 1/2, that's really 9 plus 1/2. We just put the fraction and whole number together. So we get 2/3 plus 1/2, and that gives us 4/6 plus 3/6, and that equals 7/6. And we convert that into a mixed number, and that's 1/1 and 1/6. So we added that. We added the fraction first, and then we add the whole number part. So 12 plus 9, that's 21. So then 21 plus 1 and 1/6, that gives us 22 and 1/6. So when adding mixed numbers or subtracting, so it'd be easier to add the fraction first, the fraction part first, and then add the whole number part, and then add those two together. Or you can convert both into improper fractions and then add those. But it doesn't matter which one you do. It's really the same principles of adding fractions. Yeah, so first you guys can convert mixed numbers into improper fractions. So 3 times 4 and 3/5, and 4 3/5. You convert 4 3/5 into an improper fraction. So 4/1 times 5/5, that gives us 20/5, and 20/5 plus 3/5, that's 23/5. Then we multiply this by 3, and that gives us 69/5. All right, here's some more problems. These are quite a bit of problems. So just do as much as you guys can. I'll give you guys about 10 minutes to do these, and then feel free to ask me any questions, and I'll try to answer. And I'll answer them in the chat. And I believe this is the last slide of this unit, so we will play Kahoot after these problems. And make sure you guys are all muted during this call. Okay, I'll give you guys a minute to finish up whatever problem you guys are on. Okay, I'll go over the answers right now. I realize these are a lot of problems. If you guys didn't get through all of them, it's fine, as long as you guys did as much as you guys can. The first one. So 4 and 7/8 minus 1 and 3/4. So let's add the fractions first and then the whole numbers. So 7/8 minus 3/4. We convert 3/4 into 6/8. So we get a common denominator of 8. So 7/8 minus 6/8, and that equals 1/8. And 4 minus 1, that's 3. So the answer is 3 1/8. All right, 3 1/3 minus 7 2/9. So again, we want to subtract the fraction part first. So 1/3 becomes 3/9 by multiplying by 3/3. So 3/9 minus 2/9, that equals 1/9. And 3 minus 7, that's -4. And so we have -4 and 1/9, but we don't want to just combine the whole number and the fraction. We want to add them. So -4 plus 1/9, that's actually -3 and 8/9. So that's our answer. So when you guys get the fraction and the whole number, you guys want to add them together or subtract them. You don't just want to combine the numbers. So 19 and 3/20 minus 9 and 13/15. So we want to get a common denominator of 60, because 20 times 4 is 60, and 20 times 3 is 60, and 15 times 4 is 60. So let's focus on the fractions first again. So 3/20 times 3/3, that is 9/60, and 13/15 times 4/4, that gives us 52/60. So that gives us 9/60 minus 52/60, and that gives us a fraction of 43/60. Negative 43/60. And then we subtract the whole numbers. So 19 minus 9, and that equals 10. So then we add the whole number and the fraction together. So 9 plus 9 minus 43/60. Sorry, 19 minus 9 is 10. So 10 minus 43/60. So we can turn this into 9 plus 1 minus 43/60. That's still 10 minus 43/60. And we convert the 1 into 60/60. because that's still 1. So 16 minus 43, that's 17. So 1 minus 43 over 60, that becomes 17 over 60. And then we still have a 9 left over. So that becomes 9 and 17 over 60. Okay. The fourth one on the middle left. So we have parentheses here, so we want to focus on that first. So let's focus on the fractions again. So 1/2 becomes 3 over 6. 1/3 becomes 2 over 6. So adding the fraction, that becomes 5 over 6. And 6 plus 5, that equals 11. So 11 plus 11 and 5 over 6. And then we do 18 minus 11 and 5 over 6. So we can rewrite that as 18 minus parentheses 11 plus 5 over 6. And then we use distributive property. So 18 minus 11 minus 5 over 6. And then that's 7 minus 5 over 6. And then when we subtract that, we get 6 and 1/6. Okay. So let's go over this one. So 5 and 5 over 12 times 24. So we want to convert, when we have a mixed number and a whole number and we multiply them, you want to convert this one to improper fraction because that's easier in my opinion. So 5 and 5/12, 5 over 12. We multiply 5 by 12 over 12, and that becomes 60 over 12. And then we add them, so that becomes 65 over 12. And then we multiply that by 24. Well, this is really, we can rewrite it as 60 times 1/12 times 24. And 24 divided by 12 is 2. So it's really 65 times 2, and that's 130. So this answer is 130. Okay. So let's focus on the parentheses again. So 2/3, we multiply that by 3 over 3, and that becomes 6 over 9. And we subtract that from 4. We subtract 4 over 9 from 6 over 9, and that becomes 2 over 9. And then 6 minus 4 is 2, so this becomes 2 and 2/9. And we want to multiply 1 and 1/2 by that fraction. So we want to convert both into improper fractions. So 1 1/2, that's 3 over 2. 1 1/2 is 1.5, and 3 over 2 is also 1.5. So that's the improper fraction. And then 2 and 2/9, that becomes 20 over 9, because we multiply 2 by 9 over 9, and that becomes 18 over 9. And we add that to 2 over 9, and that equals 20 over 9. So then 20 over 9 times 3 over 2, and that becomes 3 1/3. So this answer is 3 1/3. All right, so we have division first. So we want to do that first. Remember PEMDAS. Okay, so 1/3. Yeah, we want to convert this into improper fraction first because it's division. So 2 times 3 over 3, that's 6 over 3. And then we add that to 1/3, and that's 7 over 3. And then 3 1/2, we multiply 3 by 2 over 2, and that's 6 over 2. Then we add that to 1/2, and that equals 7 over 2. So that becomes 7 over 3 divided by 7 over 2, which becomes 7 over 3 times 2 over 7, and that equals 2/3. So this is really 5 1/3 plus 2/3. And when we do that, it becomes, we have the fraction 1 and 1/3 plus 2/3, that's 1. So 1 plus 5, and that equals 6. So this answer is 6. Okay, last one. All right, let's convert both into improper fractions again. So -6 times 8/8, that becomes negative 48, -48/8. And then we add that to 7/8. But we have a negative number, so when we add that, that becomes 55/8, negative 55/8. And then 3 2/3, we multiply this by 3/3. So the whole number, that becomes 9/3. Then we add that to 2/3, and that becomes 11/3. So we divide that. So we have 11/3 divided by negative 55/8. And that becomes 11/3 times 8/55 multiplied by the reciprocal. And that becomes 1/5 times 8/3, and that becomes 8/15, but we have a negative sign here. So that's negative 8/15. All right, so that was a lot. I realized I should have given you guys less than that. But yeah, as long as you guys tried, I'm happy with that. All right, so that concludes this unit. And it's time to play Kahoot. We didn't get to it last time, but we will now. So RTA Emily made Kahoot. So thank you, Emily. And this is the code. So go. Why don't you guys go to Kahoot, and then type in this code, and then you guys can start playing.
When is Kahoot going to start?
Oh wait, right now. I don't. I'm sorry. I'll give you guys the code. I forgot it was on there.
Very funny. Can we do the duplicate of Are You Smart? Can we do duplicate?
All right, here's the code.
Are you smarter
What's
than
that?
Whatever. Enter pin. Game pin. 0 1 5 3 4 0 9 4 0.
And this counts as your guys' break. If you guys don't want to play, then this is your break. So. Oh, and I'm not sure when you guys are gonna finish. So
I'm going to do another Kahoot game instead.
Okay.
Does anyone want to join me? Does anyone want to join me in this game? I'm hosting a game. Anyone want to join me?
Please stay muted or I'll mute you.
Okay.
Since that Kahoot game wasn't live, I'm not sure how many of you guys finished. So I'll just give you guys a break until I'll give you guys like 3 more minutes as a break. The game will be live next time though, so I can see who finished when.
为什么？可我总比 N 好一点。 I have finished.
I'm sorry if you guys are having a problem with the Kahoot today. It's gonna be live next time, like not separate. But
Why is there also like 2 hours and 7 minutes? Why is there like still have 2 hours and 7 minutes open?
okay, I'll get started with the new lesson right now. Okay, so unit 5 is going to be about equations and inequalities. So this is when you guys are going to start seeing variables pretty often in your equations. So this is pretty much algebra, replacing numbers with variables and trying to figure out what numbers fit that variable. So expressions. So expressions are basically a combination of numbers and variables and mathematical operations. So basically expressions don't basically are equations, but they don't have an equal sign. So if you guys look here, we have 3 expressions. So 2 plus 7 minus 3. There's no equal sign in any of these. So these are all expressions. So the first one, 2 plus 7 minus 3, there are no variables. Those all numbers and mathematical operations. 3 plus x minus 6, x is a variable. It is a letter representing a number. So, and then x squared minus 3x plus 9. This is another example of an expression. So we will not deal with expressions that have variables raised to a power. That will be for later. But let's look at some terms for our vocabulary for this unit. So terms are separated by plus or minus signs. So if you guys look at the first one, 2 plus 7 minus 3. So 2 is one term, 7 is one term, and -3 is another term. 3 plus x minus 6, 3 is one term, plus x is another term, and -6 is another term. So terms are not separated by multiplication or division. They're separated by plus and minus, addition and subtraction sign. All right, the number in a term is the coefficient. So for example, if you guys look at the rightmost expression, we have 3x. So the coefficient here is the number, and that's 3. So 3 is the coefficient in 3x. And a term that is just a number is a constant. So 2, 7, 3, 6, these are all constants. That's because the numbers will stay the same. If you have a variable, that number can, you can plug in any number for that. You can plug in 1 to x, you can plug in 2 to x, any number. But you cannot replace a number. Like, that's why they're called constants. They're constant. They will always be there. And the variables, they vary, they change. All right, so if you guys look at these pairs of equations, these are equivalent. So these are the same, but it's just written differently. So x plus 7 and 7 plus x, same, they're equivalent expressions. They are equal. So if I plug in 1 for x, so 1 plus 7, and I plug in 1 here also, they both equal 8. In fact, if I plug in anything for x, any number, they will be equal. So 7 plus any number here, they will always be equal. 1 over t and 2 minus 1 over t, they are also equivalent. That's because if I simplify this term, if I simplify the one on the right, 2 minus 1, I get 1 over t, and that is the same thing as the one on the left. So a simplified expression has as few terms as possible. There's a typo here. So this one, the one on the left is expressed in 1 term, but this, the one expressed on the right is expressed in 2 terms. So when we combine the two in the -1, we get 1, and this becomes a 1-term expression. All right, so are the following pairs of expressions equivalent? So we have -x plus 6 and 6 minus x. One way, I guess old-fashioned way to test if expressions are equivalent, you plug in a number for a variable and see if they turn out the same. So plug in 1 for x, so 6 minus 1, that's 5. -1 plus 6, that's also 5. If you plug in any variable, if you plug in any number for the variable, they will always be the same. So yes, the first pair is equivalent. But we don't need to do that. We can just tell by looking. -x plus 6, we can flip the terms, switch the order. So this and that becomes 6 minus x. So these are still the same expression. And it's important to realize that these variables are actually numbers. They're just a letter there to represent any number that we can put in. So these are still numbers, but just a letter. So letters become numbers in math. All right, t plus 1 and t minus 1. We can tell that these are not equivalent. If we flip these, this becomes 1 plus t, and this becomes -1 plus t. They're not equivalent, and we can test it out too. If you plug in any number for t, for both, if you plug in 5, they will not be the same. This one will turn out to be 6. This one will turn out to be 4. So these are not equivalent. 12x divided by 4 and 3x. These are equivalent because we can simplify 12x over 4. We simply divide 12 by 4, and that becomes 3. And we have 3 times x. We have 3x. When you guys see a number and a variable like this is really 3 times a number x. So if we plug in a number such as 3 for x, this becomes 3 times 3, so that becomes 9. But it's not necessarily 3. It's just a representation. So we say 3 times x or 3x. R squared divided by r and r. If you guys remember from the exponent rules, when we have this, when we divide powers, when we divide exponents, we're actually subtracting them. So 2 minus 1. So r, that becomes r to the 1, which is r. So these are equivalent. Although they will not be equivalent if r is 0. That's actually the one place where these are not equivalent. All right, so here's a problem. So Bob has 5 packs of gum and Joe has 6 packs of gum. Each pack of gum has X pieces of gum. So write an expression for the number of pieces of gum they have together. All right, so if you guys look here in the bullet point, so 5X. So the 5 represents the 5 packs of gum that Bob has. And the 6 represents the 6 packs of gum that Joe has. And the X here represents each piece of gum. So it's really it's a multiplication problem. So I have 5 packs of gum and each pack of gum has this many as X number of gum, as X pieces of gum. So this becomes 5X plus 6X. And we can combine those because they have the same variable. So we combine those and we get 11X. So 11X represents the total number of pieces of gum they have together. And we can prove this is right. Say each pack of gum has only 1 piece. That means Bob has 5 pieces of gum in total and Joe has 6. And then they have 11 pieces of gum. And that will be true for any number we plug in for X. All right, simplifying expressions. All right, so simplify the following expression or following expression. This is just one. So 3x plus 5 plus 4x plus 8, that equals 7x plus 13. So this is how you guys simplify them. So you guys want to find terms that have the same variable. And you want to put them, rewrite them together. So 3x plus 5 plus 4x plus 8. We get rid of the parentheses because it's all addition. So it doesn't, remember associative property, it doesn't matter which order we add them. Since it's all addition, we can rearrange the order. So this becomes 3x plus 4x plus 5 plus 18. So we combine the terms with the variable x. So 3x plus 4x. And then we combine the terms that do not have any variable. So just constants. And that's 5 plus 8. And then we combine those, we get 7x plus 13. And that is the simplified version of the original expression. So at the bottom, I bolded it. Only combine terms with the same variables. This is called combining like terms. So 5, the term 5 has no variable, but the term 4, it has an x. So you cannot combine those. All right, expanding and simplifying expressions. All right, I have a few here. I have 4, but let's focus on the top one first. So 7 times parentheses times the quantity of y plus 2 in parentheses. So we use distributive property. This is expanding. So we do 7 times y as you see here, and then 7 plus 7 times 2 as you see here. So 7 times y and 7 times 2, and then we add them together. And then that becomes 7y plus 14. And we treated y basically as a number. So that's what you do in algebra. So 6r, so let's go to the second one. So 6r plus 2 times parentheses 4 minus 3r. We have a 6r here, but we want to multiply the 2 into the parentheses. So 2 times 4 minus 2 times 3r. So this becomes 6r plus 8 minus 6r. Well, we have 6r minus 6r. We have 2 the same term, and we want to subtract them together. Subtract one from the other, and that becomes 0. So 6r minus 6r, that's 0. And then we have a leftover 8, so that's our answer. So 0 plus 8 equals 8. All right, 10t over 6 plus 12t over 9. So we have fractions. So we want to simplify these first because we can, to make it easier. So 10 over 6, we can take out a 2 from both the numerator and the denominator. So 10 divided by 2 is 5, 6 divided by 2 is 3. So this becomes 5t over 3. And we can take out a 3 from the numerator and the denominator from 12 over 9. And that becomes 4 over 3, 4t over 3. Remember, when you guys see a number and a variable together, that basically means you're multiplying the variable by the number. So this is really 10 times t divided by 6. So we get 5t over 3 plus 4t over 3. And then we add them. So that becomes 9t over 3, and that becomes 3t. So once we simplified it, 3t is the same thing as 10t over 6 plus 12t over 9. Notice this is a lot simpler than the original expression, where we had two terms of fractions, but this one we only have one term of a whole number and a variable. All right, we have more. So a over 2 plus 6a minus 5 over 4. So we want to multiply a over 2 by 2 over 2 to get the same denominator. Same principle, same rules as adding fractions without any variables. So it's basically the same thing. So a over 2 times 2 over 2, that becomes 2a over 4. So same thing as a over 2, but now we have a common denominator that we can add. So we can add the fraction. So 2a over 4 plus 6a minus 5 over 4. So all we got to do is add the numerators. So 2a plus 6a minus 5, that becomes 8a minus 5 over 4. And that is simplified version of the original expression. So what we did here is basically everything we learned already. We found a common denominator. We combined like terms. We added the numerators together, and we combined like terms. So just think of these expressions as all numbers. Don't be thrown off by the variable. Just pretend it's a number. One more example. 6x plus 21 over 18 minus 18 minus 4x over 18. So we have the same we have a common denominator already. So all we got to do is add the numerators. So 6x plus 21 minus parentheses 18 minus 4x. Some people make this mistake. They only subtract the 18, but they don't subtract the negative 4x. When you're subtracting a fraction like this, you're really subtracting 18 minus 4x in parentheses. So we utilize the distributive property here. So this becomes 6x. Once we multiply the negative 1, remember there's an invisible 1 here, the negative 1 into the parentheses, this becomes 6x plus 21 minus 18 plus 4x. So that becomes 10x plus 3 over 18. Okay, here are 5 challenge problems. Some practice for combining expression. So, or combining terms. So I'll give you guys about 8 minutes to do these. So remember, just treat the variable as a number. And remember, only combine terms, only combine like terms. If one has a variable and one does not have a variable, you cannot combine them. Only if they have the same variable. Okay, about 1 more minute. Okay, I'll go over the answers right now. All right, top right, top left, first one. So 2r plus 3r minus 7r. So all we got, they all have the same terms, same variables. So all you gotta do is combine them. So 2r plus 3r, that's 5r, and 5r minus 7r, that is negative 2r. So the answer is negative 2r. 3y minus 2y plus 7y minus 9y. Again, all the same variables. So 3y minus 2y, that's y. Y plus 7, that's y, or 1y. When it's just a variable such as y, note that there's an invisible 1. So 1y and y, those are the same thing. So y plus 7y, that's 8y. And 8y minus 9y, that's negative y, or negative 1y. When it's negative 1y, we more commonly say negative y. We just ignore the 1 because we know it's there. All right, 7 times the quantity of x minus 2 plus 5 times the quantity of 2x plus 3. So we distribute it. We distribute the 7 into it and the 5 into the parentheses. So this becomes 7x minus 14 and 10x plus 15. So 7x plus 10x, that's 17x. Negative 14 plus 15, that's 1. Because that's the same thing as 15 minus 14. So that becomes 17x plus 1. All right, 4 times 3a minus 4 minus 6 times 2a minus 1. So we multiply it into parentheses again. So 12a minus 16 minus 12a, there's a minus sign here, minus 12a plus 1. And that becomes, well, we can cancel out the 12a because 12a minus 12a, that's 0. And then we have negative 16 plus 6, and that's negative 10. So our answer here is just negative 10, no variables. All right, x minus 7 over 3 minus 5 minus x over 2. So we want to multiply, we want to get the common denominator of 6. So we multiply the left term by 2 over 2, and we multiply the right term by 3 over 3. So this becomes 2x. Once we do that, we get 2x minus 14 over 6 minus 15 plus 3x over 6. Sorry, it's all over 6. So we get 2x minus 14 minus 15 plus 3x. Everything, all of that over 6. And once we combine like terms, we get 5x minus 29 over 6. Okay, solving linear equations. So this is probably the easiest thing you guys will do in algebra, or the first thing you guys will learn how to do in algebra. So an equation states that two quantities are equal. We know that. We've been solving equations forever. And an equation has an equal sign, but expressions don't. We also know that. hence the name equation equal. We solve an equation when we find all values of variables that make the equation true. So when we solve for a variable, it doesn't necessarily necessarily only have one answer to it. It can have an infinite number of answers. It can have 2 answers, no answers, but we don't know until we find out. So whatever we do to one side of the equation, we must do to the other. So this is the basic principle. This is probably the most important principle of algebra. Whatever you do to one side, you do to the other. That's how you keep the equations equal. If I subtract 1 from one side of the equation, I have to subtract 1 from the other side in order to keep it equal. Okay. So look on the left, we have x plus 3 equals 9, and we want to solve for x. So if you guys want to solve for a variable, you guys want to get that variable by itself on one side of the equation. So you want to get the x by itself. But we have a plus 3 here. So how do we get the plus 3 to the other side? Or how do we get rid of the plus 3 on this side? So what we do is subtract 3 from both sides of the equation. So x plus 3 minus 3, that just becomes x. And 9 minus 3, that becomes 6. So we're left with x equals 6. And that's our answer, x equals 6. And that's true because 6 plus 3 equals 9. I understand you guys probably know the answer to this one without subtracting 3 from each side. But once you guys see more complex equations with variables, you guys are going to have to follow the steps, solve it step by step. You can't just guess which one it is. You can't just look at it and see and guess which variable it is. And one example of that is on the right side. This is a lot more complex than the one on the right side. So 5x minus 4x plus 3 equals 14. So we can start by combining like terms. 5x minus 4x, that's just x. So x plus 3 equals 14. And we want to subtract 3 from each side. So x plus 3 minus 3 and 14 minus 3. So the 3's cancel out, but 14 minus 3 is 11. So x equals 11. And this is true because when we plug in 11, when we replace x with 11, the equation is true. Because 5 times 11, that's 55, minus 44, that's 11. And 11 plus 3 is 14. So that's how you guys can check if you guys actually got the right answer. In algebra, all you have to do is once you guys get an answer, you guys can plug that answer back into the equation and for the variable and see if the equation is true. Say we got x equals 5 and we plugged in 5 for x back in the equation. It's not going to be true. That means we did something wrong somewhere, and that's how we know we need to start over. So you can always check if you have the right answer in algebra. All right, linear equations contain constants and variables raised to the first power. So they're called linear equations because when you graph it, this is called a Cartesian plane, or just a graph, a common graph. We see lines, hence the name linear, with line. So for equations that only have constants and a variable to the first power, you guys will always get a line. That's why they're called linear equations. And on the right side, we see one that is not linear. Y equals x squared minus x minus 2. This is not a linear equation because of the x squared. This is actually called a quadratic equation. You guys will learn about this later in math. But right now, we're just going to focus on linear equations. Okay, so I have a lot of examples here, but let's just focus on the one on the left. All right, so x minus 12 equals 289. And we want to solve for x. So we add 12 to both sides. So this cancels out. And 289 plus 12, that equals 301. So x equals 301. All right, 31x equals 713. What does x equal? Well, when we have multiplication like this, 31 times x, we want to divide. So we divide each side by 31. So this becomes just x, because 31 divided by 31 is 1. And 713 divided by 31, that's 23. So x equals 23. So if it's addition, you subtract. And the other way around. If it's multiplication, you divide. And also the other way around. All right, x minus 4 2/3 equals 2 4/5. So we add 4 2/3 to both sides. And we get this number, whatever, I didn't combine it, but whatever this number becomes, that's our answer. All right, one more. So negative 2r over 9 equals 8 over 15. So we have negative 2 over 9 here. And we put that in parentheses. And all we got to do is multiply by the reciprocal to get the r by itself. This is the same thing as dividing by negative 2 over 9. So once we multiply by the reciprocal on both sides, we get r equals negative 12 over 5. Okay, so we will stop here for today. It is 7:29. So I will see you guys. We'll start back here on Tuesday. And I'll see you guys then. So thank you guys again for attending.
Thank you. Bye.